How does the Laplace transform table look like? There are two types of Laplace table. The first table lists all of the properties of Laplace transformation. So this is the first table of Laplace. This lists the properties of Laplace transformation. So I'll show this first table, the property of Laplace, in 2 slides because it doesn't fit in 1 slide. And then the second table is the Laplace transformation table that lists a pair of function in time domain, Laplace domain. So if you look at this, the first column lists the function in time domain, where the second column shows the Laplace counterpart of the time domain function in the first column. For example, if you look at the third row here, function of time ft equal to t, so which is linear to time. If we have a function of t in Laplace domain, it will look like this. In Laplace domain, function of t equal of t will be equal to 1 over s squared. There are 2 functions in this table that I want to discuss in particular. The first one is delta function. What is delta function? Delta function is what we call as impulse function. How does an impulse function looks like? Impulse function looks like this. The value of impulse function is equal to 0 for all over t, except when t is equal to 0. When t is equal to 0, the impulse function will have an infinite value. So it's 0 for negative t, infinite value when t is equal to 0, and then again 0 for positive t. That is the first function, delta function, or we call it as an impulse function. The second function is a step function. I indicate it here as UST. How does it look? For UST, for step function, the value of this function is 0 for negative t. And for 0 and positive t, the value is equal to 1. Okay, so it's 0, and starting from time equal to 0, the value is equal to 1. So that is what we call as a step function. The rest of this function is pretty straightforward. The third function is a function of time, ft is equal to t, a linear function in time. The fourth function is time power of n. N can be any number, 1, 2, 3, 4. And the fifth function is exponential of minus at. A is a constant. And then on this row, you can see the Laplace counterparts of this function. This table doesn't end here because this slide is not sufficient, so I split it into few slides. This is also same table for any other function in time and Laplace domains, and then this is the third part of the same table. Okay, as you can see here, one of the function is sine at. A is a constant again in Laplace domain. The Laplace counterpart of sine at will be equal to a over s squared plus a squared. Okay, so these are the 2 tables that you need to convert function from time domain to Laplace domain and vice versa. Just for our convention, just to make our communication easier perhaps, normally I always use lowercase letter to denote function of time. So I use ft with a lowercase of f to denote a function of time. For instance, ft with lowercase equal to 2t, a function of time. But then normally I use capital letter to denote a function in Laplace domain. So for instance, if I have a function in Laplace domain, I normally indicate it with a capital letter of F. Function of Laplace S, f of s is equal to 2 over s squared. This is just an example of a Laplace domain function. So let's say if I have a function in time ut, okay, I denote it with a lowercase letter for a function of time. If I Laplace this function in Laplace domain, I will denote it as a capital U of s. This is just a common notation that I will use. This is also same notation that is used in the textbook. So let's talk a bit about some examples on Laplace transformation.